Um, yeah, that circle's not that bad. This, of course, would be the center, right? Um, so I'm going to label some points on here. I'm going to call this O. I'm going to call this point here A. I'm going to call this point here B. I'm going to call that C. And that one D. So when I draw a line from there to there, what is that line called?
The radius.
What if I draw a line from there to there? What would that? What would the whole line be called?
Diameter.
Okay. And you know that 2 of the radiuses is equal to the diameter,
yeah.
Right? What about if I say the circumference of the circle?
Just the measure of the whole circle around.
Okay, so it's just like doing the perimeter of the circle, right? Do you remember the formula for that?
I know somewhere in there, like, 1,000 sheets.
So that's 2 pi r, right? So I can figure out what this whole perimeter is by using that formula. How many degrees are there in a circle? 360 degrees. So this is kind of the same thing as saying 2 pi. So you need to remember that 2 pi is the exact same thing as saying 360 degrees. Okay? If I wanted to find the area of a circle, that equation is pi r squared, right? Same pi, same radius. From here on out, you will not be using 3.14 for pi.
Just the pi.
You will just be using the symbol pi. Okay. So now I'm going to talk about something called arc length. Arc length is just some piece of the circumference, right? So if I were to draw another line from here to here, both of those are radiuses, right?
And then that segment of the circumference.
And that segment of the circumference would be the arc. So there are 2 ways to measure the arc. You can do arc length, which is that symbol, or you can do arc measure, which has to do with how many degrees. So let's say this is 40 degrees. Now let's make it 45. Let's make it 60, just to make it almost right. Okay, so let's say that that's 60 degrees, right? This angle is called a central angle. And the central angle and the arc measure are exactly the same. So that would be 60 degrees. If I want to find the arc length, then I need to figure out how many I need to figure out the fraction of the total, right? So if I'm only taking 60 degrees of this perimeter,
so this is 300.
So it would be over 300. So you would do 60 divided by 300. Sorry, 360. Oof, let me try that over. 60 divided by 360. Because how many degrees are in a circle total?
60.
And how many degrees am I taking?
Just 60.
Just 60. So you actually divide those two with one another. And then if I want to figure out what this arc length is, I just multiply by their circumference. So you would do 2 pi times r. And that's going to give me what that arc measure would be. So let's say this radius is 4. Then I'm going to reduce this fraction first. So that's 1/6. And then I'm going to multiply it by 2 times pi times 4. Well, this cancels that and makes that number 3, right? And so that would be 4 pi over 3. That would be that arc length. So whenever you do arc length, you just take the number of degrees for the arc, you divide it by 360, you make it into a fraction. You notice I didn't write a decimal there,
Yeah.
right? And then you just multiply that by the circumference. So if I do arc length, it's equal to some fraction times the circumference. So let me draw a couple of these up. That's not as good. Let's say that this is 8, and that's O, and that's A, and this is B, and there's 120 degrees there, and I'm going to put a C there. You can label things in terms of major arc or minor arc. The minor arcs have a measure less than 180 degrees. The major arcs have a measure greater than 180 degrees. So if I'm going to label this circle, AB arc would be the minor, and then BCA. Notice that I'm putting them in order of how I get to them, right? That would be the major. And now I'm going to find both of those arc lengths. So to find the arc length for AB,
120 over 360.
B, times
The circumference, which is 2 pi r squared.
2 pi, just regular old r.
Yeah.
So now I'm going to reduce this. The 2 zeros reduce, and then 12 goes into 360 how many times?
1/3.
Good. And then what's that times that?
So 16.
So that would be the answer.
Yeah.
Okay. So
I'm probably gonna forget because I'll probably do like something like 1/3 times 16 pi or something like that.
well, if you write it like 1/3 times 16 pi, then you have to multiply the two tops together, right? You could put this over 1 and then just multiply it, and then you'll end up getting the same answer. Remember, when you're multiplying with fractions, top numbers multiply top numbers, bottom numbers multiply bottom numbers. So you can put it together, and that's the way they're going to want the answer. So let's do the major arc.
So 240 over 360
times
2 pi.
So what's 2 pi? What's 2 pi r?
It would be the same.
It would be the exact same. That's what I want you to see. I want you to see that that's going to be.
It's the same no matter.
Yeah. The circumference is always going to be the same. It's just it depends on the piece that I'm taking, right? All right. So simplify that. Zeros cancel. What's the biggest number that goes into 24 and 36?
12.
Okay.
So 1/2. Oh, 1/3. Yeah. 1/3.
2/3, right?
Oh,
I mean,
so 12. Yeah.
Top numbers multiply top numbers, right? So what is that going to be equal to?
32 pi over 3.
And so that would be BCA. Okay. So all you got to remember is circumference deals with arc length. And it's some kind of fraction. That's all you have to remember. Now I'm going to erase some of this. Maybe I can actually, can I grab just a piece of this? No. What about this button? No. Oh, okay, just have to do it the long way. Oops.
It's just some kind of like Google
Yeah.
app or something.
Yeah, it's a whiteboard that's online. Like when I'm working with kids and I'm at home and they're at home, like I'm working online with them, this is the one that I use because it's the most stable and it's free, which is always good. Okay. Now I'm going to do sector area. So, oops, that wasn't helpful. Sector area has to do with the exact same fraction, but now instead of using circumference, I'm going to use the area equation. And when I'm talking about sector area, if I was saying the sector area for BOA, that would be all of this area that I have shaded there.
So it's the difference, just the area, and then just
and then just the perimeter, right? So it's the exact same formula except for I'm changing it to the area formula. So I'm going to use the exact same fraction. So we found out that was 1/3, right? And then I'm going to multiply it by pi r squared.
Okay, so 64 pi over 3.
Pretty simple, right?
Yeah, so that's just the whole answer?
That's just the whole answer. So the only thing that you switch when you're going from arc length and sector area is you're just changing that one part. You're still gonna find the fraction first, and you take the fraction and you multiply it by the area equation. Or if you're finding arc length, you take the fraction and you multiply it by circumference. They're not going to teach it that way in school. They're going to do something that looks like this. Right. That's what that equation actually means. It means how many degrees do you have, and then from those degrees that you have out of 2 pi, you multiply it by the radius, and it gives you the sector area.
So do you think they'll just, they're still talking about sector area, so I'll be able to tell the difference between
sector area and arc length, right. Yeah. I'm teaching it to you in a way that you will actually understand.
That's good.
So just know that is the sector area equation, and that equation is basically doing the exact same thing that I'm showing you here.
Okay.
Those two things are one and the same. So let's see if I can get some questions from my software out on this stuff. And it's probably a good place to stop because you're probably going to be doing that circle stuff that we just did, completing a square, and then this next. That's normally what happens. And then we'll get into secant and tangent and inscribed angles and all other stuff later on.
She said we'll be doing this by the end of next week, Friday, which doesn't really make sense because I don't know what we'll be doing Monday and Wednesday.
By the end of next week, Friday?
Yeah, so by the...
So, how many times do you see her next week, though? You see her twice?
Well, we see her Monday, Wednesday, and Friday next week. And she said we're going to be, starting that Friday. So I don't really understand how that's working.
Oh. So what are you going to be doing all next week?
Yeah.
You don't...
No. It can't be
you might be doing this first. Because normally teachers teach this stuff first.
Okay.
But we'll see. Let's see here. Okay, so let's do some of this stuff. It doesn't require any math necessarily. I just want you to recognize some stuff. Okay. take the answers away too. All right. Answer the first question for me.
SUT, so is it asking for the...
It's asking you for the angle that's part of that. S,
So
U.
3? It's like the angle that's supposed to be where 3 is, or...
Well, if I'm doing the arc and it's 3, right? It would be S through U and then T.
Oh, okay.
Right? So what one angle would represent that? Give me the major angle and the minor. The major arc and the minor arc. So if I'm doing SUT, how would I figure out what that angle is? What would I have to do to these angles inside to figure out what that angle is?
Divide them by 360.
No. Okay. When you're doing arc measures, right? All you do is just add up the central angles inside. So if I'm going from S to U to T, then it's this major arc here. That would be 1 plus 4 plus 3.
Okay.
If I'm doing the minor arc, which would be that one, then it would just be angle 2. Do you see that?
I don't really see the difference between the minor and major arc. Like,
Okay.
how do you depict from that?
Let me simplify that same picture. And I probably should put T like right about there, actually. So let me see if I can. So I'm going to put T there. Okay. So S, U, T. Is that amount of degrees greater than or less than 180?
It's greater than.
It's great. That makes it the minor arc because it's greater than. So you would have to take all of the angles that you have on this side to figure out what that angle is.
So the larger segment is the minor.
The larger segment is the major. So like if I'm going to shade this, that's more than half the circle, right?
Yes, that's major.
So that's the major.
Okay.
So the minor would be
that part.
That part, and that was angle 2.
Okay.
Okay? So you can either give the degrees for the major, or if there's one angle, you can define it by the minor. Okay? But it's telling you the direction to walk because it said S-U-T. So you have to go from S to U all the way to T.
Which is 8, right? Something like that.
Yeah, it was like 4 and 3 and 2 and 1 in here. So you would have to add up all 3 of those to get to that angle. All right, let's look at the other one. Okay, let me blow this up. Okay, so we're going from I to G to J.
So it'll just be I, J, G, right? Doesn't matter.
Well, it does matter the order, but you can't really do that because, well, I guess I can go from I to G to J. I can do that.
So it's including H also?
So it's including H also.
So everything's just except for that segment that 3 is in.
So it's everything except for angle
3.
3, right. Okay, so they want you to label the major arc for angle 4. So here's angle 4. So the minor arc would be what?
F. What was that, J?
That's an I.
I.
So the minor arc would be Fi. Label a major arc for me.
F, G, H.
F, G, I. You got to go all the way back to I.
So why wouldn't the minor arc be just like F, I, H? Or like.
Well, if I'm talking just about angle 4, right?
Angle 4, just angle 4. Then it should be F, I. Okay.
Then it would be Fi. But if I'm talking about the major arc for Fi, then it has to be the other part of the 360 degrees. So I have to walk the long way around the perimeter.
So the major arc would be named just FGI.
FGI, right.
Okay.
Right. Or you could name it FHI, either way. Because you're still walking the same direction.
Okay.
Okay, do that one.
Just name it major and minor.
Yeah, name the major and minor. So tell me the central angle that represents TW.
4.
4.
Yeah.
4. Tell me the major arc that would represent TW. That would be the complement to TW.
TUW.
TUW. Right. It's just walking the opposite direction. Yeah. Tell me the central angle that represents GEF.
So E is just marking the circumference, right?
Right.
Or is it?
So walk with me. G, and then I'm gonna go walk all the way over to E, and then I'm gonna walk over to F. So what central angle didn't I cross?
2.
2.
Okay.
So that's the same as that. That's the central angle that represents that major arc.
So 2 is?
2 is.
Okay.
See? Because 2 has both a major and a minor arc, right? What would the minor arc for 2 be?
GF.
So what would the major arc for 2 be?
GEF.
You see how that works?
Yeah.
All right, I'm done. Okay. Let me stop this.